JS is a weird language, and it has so many secrets and advanced tips. In this playlist, we are going to deep dive into every single one of them one by one. Let's see! Okay, in this video we are going to talk about reference type and value type and give you some examples to understand some unexpected behaviors in JavaScript. When we use computers and when we use a programming language to allocate memories for variables, the variables can be stored in stack or heap in memory. In stack we have a stored value and they are exactly stored there. For example, if you say let x equals to 5, we would have a x in the stack and its value would be 5. But some other values like objects and arrays are not value types, so they are stored in heap because they can be huge, they can be small, we don't have exact estimation for the space they need. Maybe we need to garbage collect them, maybe we need to mutate them, so we cannot store them in the stack memory, so we create a reference from a stack to heap for them. For example, if you say we have an object, for example user object, it has a name and its name is Mehran, we would have a user in the stack which is pointing a reference, and that reference points to the heap. So when you console.log user, the JavaScript exactly looks for the reference value in heap from the value stored in the stack, and it would log the object in the console.log. Okay, let's see it in the example and let's see it in the action. First of all, we're going to introduce the value types. One of the value types are numbers. For example, in here, when you say, let me make this a little smaller. Okay, when we say a equals to 10, we would have a brand new a equals to 10 in the stack memory. And when we say b equals to a, we would have a brand new 10 which is assigned to b in stack. And if we assign another value, a remains in the stack unchanged and b would assign to a new number which is 20, and when we console.log a, we would see 10, which is exactly the initial value of the 10 which is unchanged. Okay, such as you see in the console, we're going to see the exact 10 number. But what about the reference types? I have a great example in here and a simple one, by the way. Okay, we have a object 1 which name is Alice. No, it is not Alice, it is Mehran. And it's codizoo _IR channel. Don't forget to subscribe to the channel. Okay, we have a object, it has a name. The name Mehran is stored in the heap, not in the stack. And when we assign the object to another object, it wouldn't duplicate the name Mehran. It would duplicate the reference in the stack. For example, this pointer, which is pointing to the object from here, is duplicated, and the object is just one object. And in here, when we try to change the name of the object to, and when we console object 1.name, we would see an unexpected behavior which is actually new value in the object 1. We change the object 2, but object 1 is changed. Why? Because we don't have totally two separated objects, we only have one, and when we try to change it one place, it would reflect to the other places. In the line 7, we just duplicated the pointer, we didn't duplicate the object. If we want to duplicate the object, we would try another ways. For example, we can use a spread operator in here and make a totally brand new object. Now the points is not copied. It totally created a new object and assigned it to object 2 with a totally brand new reference type. And when we log it, such as you see, we see Mehran in object1.name, and we don't see codizoo underline ir, because this time we totally created a brand new object with a brand new reference type. Let's try another thing. What if we want to prevent this to be happened? For example, we don't want an object to be changed. We can use object.freeze on the object, so make it unchangeable in keys and values. If you don't know what is object.freeze, I have recorded a very magnificent video about object.freeze. You can watch it in my JS Quiz Explain playlist in my YouTube channel. Okay, in here, if you try to do it, it will throw an error which says the property name of the object is read-only and you cannot change the name. Okay, this makes the object non-immutable. If you change the object without changing its reference, we say we immutated the object. Object.freeze prevents immutation of the object. By the way, there are some other methods like object.seal and object prevent extensions, which I explained it to you in that video. I will add the card to that video in here so you can watch it if you want later. What if we want to deep clone the object? There is a technique to deep clone the object, which we can stringify the object and then parse it again, so we have a totally brand new object. What is the difference between this and actually a spread operator? Can you guess it? What is the difference between deep clone 1 and deep clone 2? Okay, deep clone 1 actually deep clones all nested levels of the object, but deep clone 2, which is actually just a spread operator, just clones the first level object keys in this object. If you have, for example, 3 levels of objects, you need to do this nested 3 times to make it a deep clone. So the spread operator just clones the first level of the object references. Okay, another interesting topic which is defined in here. What is reference type and what is value type? A very great question which I have mostly faced in front-end interview questions, and it was a very interesting one. Value types are passed by value. For example, I have a function in here which accepts a x and assigns x to 20, and if we log it, for example, log x inside the function, we would definitely see 20. Okay, and in line 21 we have a number which is equals to 10, and we update the number and then we console.log the number. Let's see the result. Okay, such as you see, x inside the function is 20, but outside function is 10, which is unchanged, and it's exactly the initial value which is defined in line 21. Okay, this is pass by value. When you pass by value a variable to a function, the function can modify the value just inside that function, and it's untouched outside of the function. Okay, what about the other one? What about reference types? Okay, let's see. In here we have update by ref. reference types are passed by references. In here, instead of accepting a value type, it's accepting an object. In the line 31, we define the person with name Alice, and we update it by ref to person, and let's like object in function and the obj and in here we are going to like the object outside of the function. In here I should log the person. Okay, we define the person with name Alice, and we update by ref the person, and in the update by ref we change object.name to Bob, and in the function we'll log the obj, and after calling that function we log the person. But such as you see, if we try to run the code, in the function we see the name is Bob, and it's outside of the function the name is Bob again. And such as you see, whereas value types, which is unchanged outside of the function, but reference types are definitely changed outside of the function. For example, in here in line 33, the person is completely changed due to this mutation we made in line 27, and this is update by ref versus update by value, or pass by ref versus pass by the value. Hope you enjoyed the video. Don't forget to subscribe to the channel, and if there is a topic you want me to create a video about it, just comment below. Thanks for watching.